Welcome to RCC's Math Tape 051, Introduction to Rational Numbers. As you watch the tape, be sure to take careful notes. Mark on your notes any place you don't understand or any problems you miss when you work the exercises that I shall give you. Then be sure to ask a lab instructor or a tutor for help when you go to the lab. We have two objectives. Determine the correct order relationship between two given rational numbers, and determine the absolute value and the opposite of given rational numbers. We're working with rational numbers, and that means we need to know what rational numbers are. So what we'll do is begin by looking at sets of rational numbers, defining the rational numbers, and then we can perform our objectives. Let's start by taking a look at the set of integers. The integers are the whole numbers, 0, 1, 2, 3, and so on forever, and the opposites of the whole numbers, or the negative integers. The opposite of 0 is itself, because 0 is neutral. The opposite of 1 is negative 1, the opposite of 2 is negative 2, the opposite of 3 is negative 3, and so on we go forever. So the integers include all the negatives of the whole numbers and the whole numbers themselves. We often look at the integers pictorially by placing them on a number line. To draw a number line, which you should do in your notes, you draw a line, place 0 about in the middle of your drawing, and then equally spacing, place the positive integers to the right and the negative integers to the left. The spacing between 0 and 1 is 1 unit, between 1 and 2 is 1 unit, between 2 and 3 is 1 unit, and so on. And so the spacing between these should be the same in either direction. So here are the integers, positives to the right, negatives to the left. The rational numbers are the numbers that can be written as ratios of integers, such things as, for instance, 1/2. Well, 1/2 would be halfway between 0 and 1. If we look at all the rational numbers that occur between 0 and 1, we get not only 1/2, but things like 1/3, or 3/4, or 9/10, or 1/billionth, or 3/10,000ths. You catch on to the fact that there's no way we can list all of those rational numbers between 0 and 1. And that's just a beginning, just 1 unit. To list all of the rational numbers is impossible. There are too many. And so we have to resort to a different way to define the rational numbers. The rational numbers are defined by writing down a formula, A over B, a fraction. We read this vertical bar such that A over B such that A and B are integers and B does not equal 0. The denominator of a fraction is never ever allowed to be 0. So when we define rational numbers, we make that statement. So here's what the rational numbers are. The set of all A over B such that A and B are integers, B does not equal 0. For examples of the rational numbers, 1/2, integer divided by integer. Negative 2/3, integer divided by integer. 11/4, integer divided by integer. Anytime we have an integer divided by an integer, that gives us a rational number. Let's put these rational numbers on a number line. Here's a number line, and for 1/2, we would place the indicator for 1/2 as a dot exactly halfway between 0 and 1. So we'll put 1/2 halfway between 0 and 1. For negative 2/3, negative 2/3 is to the left of 0 on the negative side, but it's only 2/3 of a unit from 0. So we'll divide up the unit between 0 and negative 1 into thirds. And we want to go negative 2/3. So from 0, here's negative 1/3, here's negative 2/3. There's a location for negative 2/3. 11/4 presents a bit of a problem because the numerator is greater than the denominator. It will probably be easier for us to place 11/4 on the number line if we write this in mixed number form. So let's do just that. Divide 4 into 11. We get 2. 2 times 4 is 8. Subtract and we get 3. And so that means that 11/4 is the same as 2 and 3/4. Now we can place 2 and 3/4 on our number line. That's in the positive direction. 1, 2, and 3/4. That means we would divide the number line up into 4 pieces for this little unit. And 3/4 would be 1, 2, 3 of those fourths to the right. And there is 11/4. Another example of a rational number is the rational number negative 3 over 1. Negative 3 over 1 is the same as negative 3, and so that means we can locate negative 3 on a number line in the place that it already occupies. There's negative 3. One more example of a rational number is the rational number 0, which we can write as 0 over 1. Notice that the denominator is not 0. Our definition says the denominator can never be 0, but it's fine for the numerator to be 0. And so the rational number 0 can be placed on the number line, and here is 0. So you see that all of the integers that we had on the number line at the outset, the ones that are labeled below the number line here, are rational numbers. And there are infinitely many more rational numbers that are not placed on the number line at the outset that we can locate as we've done here. Now, as we worked with 11/4, we wrote 11/4 in mixed number form. Recall that a fraction can be written as a fraction or as a decimal. And one thing we're asked to do from time to time is to convert fractions to decimals. So let's take just a moment to convert some fractions to decimals. Converting 11/4 to a decimal, the same number that we just were working with. When we convert 11/4 to a decimal, we divide the denominator 4 into the numerator 11. We get 2. 2 times 4 is 8. Subtract and get 3. But to go with decimals, we place the decimal point where it's understood to be to the right of 11 and affix a 0 to the right of that so that we can bring down the next digit and keep dividing. In the quotient, the answer, the decimal point goes directly above its present location, and we continue dividing. 4 divides into 30 7 times. 7 times 4 is 28. We subtract and get 2, and another 0 affixed to the dividend lets us bring down 0. Divide 4 into 20, and we get 5. 5 times 4 is 20. The remainder is 0. And so our answer is that 11/4 is the same as 2 and 75 hundredths.